Hello and welcome. We are going to solve another interesting question. All right, if you look at this, this is a simple supported beam with 3 load, 1 point load and 2 inclined load. All right, so for us to solve this, we are going to be replacing this support here with a reaction at what? At a B. So this is going to be reaction at B. All right, while this is going to be reaction at A. All right. So, so that's it. Now, the next thing we are going to be doing is this. We are going to be resolving this inclined load into what? Into X and Y direction. All right. So for us to do that, we are going to draw a dotted line down like this for us to make the work simple for us. So draw another dotted line here. All right. So again, draw another dotted line in this angle. All right. So everything we intersect at this side here. Everything should intersect here. All right. So let's draw another one here. Right. All right. All right. Now, the reason why we are doing this is this. So if we call this place our Y1, and we call this one our Y2. So this place is going to be our X1. This place too is going to be what? S1. This place too is going to be what? Y1. So the distance from here to here, which is Y1, is also the same thing as Y1. The distance from here to S1 is also the same thing as S1. So this place too will be what? Y2. This will be S2. This place too is going to be what? S2. And you are going to take note of something, that this is the inclined. This is the inclined load. Do you understand? You can see the arrow here. So it means that this S direction is going to be coming towards this direction, then towards this direction. So similarly with this. All right, so that is it. So take note of that. Now, how do we get our X1 and Y1? All right, for us to get S1, I'm going to take note of this. So here we are going to have our 90 degree here. So here we are going to have 90 degree here. All right. So now we are going to consider sine theta here. If you consider sine theta is what? Sine 30. Opposite over what? Hypotenuse, right? And our hypotenuse is 350 here. So we are going to have sine 30. Sine 30 to be equals to opposite. Our opposite is Y1. All over what? All over 350. So forget Y1. Y1 will be equals to 350 sine what? Sine 30. It's going to be 350 sine 30. So if you press this in your calculator, our Y1 is going to be equals to what? 175. 175 Newton. All right, so that is our Y1. So for us to get our X1, our S1 is going to be cos. So from cos 30, I'm going to have cos 30 to be what? Adjacent over what? Hypotenuse. That is S1 all over what? 350. So which is going to be what? S1 will be equals to 350 cos what? Cos 350. Sorry, cos 30 rather. All right, so X1 is going to be equals to what? 303.11 Newton. All right. So similarly with this, we are going to consider sine 45. Sine 45 will be equals to what? Opposite. Our opposite is Y2. So we are going to have Y2 all over what? All over 300. So our Y2 will be equals to 300 sine what? Sine 45 rather. So now our Y2 will be equals to what? 212.13 Newton. All right. So the next one is cos. So we're going to have cos 45. It will be equals to adjacent, which is what? S2, all over what? All over hypotenuse, which is 300. So this will be equals to, our S2 will be equals to 300 cos 45. So S2 will be equals to what? 212.13 Newton. So that's what we have. All right. So we have our horizontal force and then we have our vertical forces. Exactly. All right. So here we are going to start with the summation of horizontal forces to be equals to 0. So here we'll be taking this direction to be positive and anyone coming this direction to be what? Negative. All right. So now if you look at the two forces that we have here, for S1 is going in this direction, so it's going to be positive. While this one is going in this direction, it's going to be what? Negative. So it shows that we are going to have the summation of horizontal force here to be, all right. So now you know, this our fixed support, we are going to have both horizontal and vertical reaction here. So we are going to have arrow H. So we are going to have an arrow here, arrow H. Let me clean this A here. All right, so we are going to have an arrow here, which is going to be arrow H. Let me write it well. Arrow H. So this is our A. So now it means that arrow H2 is going in this direction. So it's going to be arrow H. All right, plus what? Plus S1. Our S1 is what? 303.11. Then our S2 is going in this direction, minus 300. Everything equals to what? 0. So if you subtract this, we are going to have this to be what? So we are going to have this is plus 3.11 to be equals to what? 0. So our horizontal reaction will be equals to minus 3.1 Newton. All right, so that's it. So here the next thing we are going to consider is the summation of what? Vertical forces to be equals to what? 0. So we are going to take our upward force positive and our downward force to be what? Negative. All right. So now the sum of our upward force, are going to have arrow A plus arrow B to be equals to, our downward force is going to be what? 250 plus what? Plus Y2. Y2 is a downward force, Y1 is a downward force. Our Y2 is what? 212 point what? 0.13 plus our Y1. Our Y1 is 175. So by the time we sum this together, what do we have? 6 what? 0.13. All right. So that's what we have. So let's call this one equation number 1. So the next thing we are going to do is we are going to take our moment about what? About point A. So summation of moment about point A will be equals to what? 0. All right. So it's going to be arrow B. But don't forget, our upward force is positive, downward force is what? Negative. So it's going to be what? Arrow B multiplied by what? The total distance here is what? 10. That is multiplied by 10, which will be equals to 250 multiplied by what? 250 multiplied by 6. 250 multiplied by 6. That is from this point here down to this point. This is the first, this is the distance. All right. So then we are going to have Y2, which is 212 plus 212.13 multiplied by what? Multiplied by 3. All right, but and the next force, which is Y1. Y1 is 175 multiplied by 1, which is what? 175. All right, so this is going to be 10 arrow subscript B will be equals to 250 multiplied by 6. That is 1,500 plus 212 multiplied by 212.13 multiplied by 3. 636.39 plus 175. So by the time we sum that together, we are going to get 2311.39. So if we divide both sides by 10 now, we're going to have this to be 22, that is ROB will be equals to what? 231.139 Newton. All right, so that's what we are going to have. So for us to get our ROA now, our ROA will be equals to 673.13 minus ROB. That is 637.13 minus 231.13.9. It's going to give us what? 405.991 Newton. So that's what we are going to get. Now, the next thing we are going to be doing is we are going to calculate our shear force. That is, we are going to our shear force calculation. All right, so that's it. So now we are going to take the shear force at point B. All right, the shear force at point B is the reaction at point B. We stand at point B towards our right. We don't have any force rather than reaction at point B, which is what? Upward force, which is what? Positive. So it's going to be 231.139. All right. So the next one is shear force at point E. All right, the shear force at point E is, we stand at point E here. We have two forces here. If we stand here, that is the upward and the downward. That is ROB minus 250. That is 231.139 minus 250. So if we do that, what are we going to have? Minus 18.861 Newton. All right, this one too is in what? Newton. So the next one is the shear force at point D. The shear force at point D will be equals to, all right, so the shear force at point D is going to be ROB minus 250 plus what? Minus what? Y. And don't forget, we've already gotten the summation of these two forces, which is what? Minus 18.86. So if we subtract Y2 from that, our Y2 is what? Our Y2 is minus 212.13. So this is going to give us what? Minus 230. Point what? 911. 991. All right, Newton. All right, so that's what we have. So now we are going to go for the shear force at point C now. So the shear force at point C will be equals to, all right, so we have gotten to the point of D, which is what? Minus 230.991. All right, so if we subtract Y1 from this, because it's also a downward force, right? It's also a downward force. So minus Y1. Our Y1 is nothing but what? 175. Minus 175. So if we do this, what are we going to have? Minus 405. 405.99 what? 1 Newton. All right. So we are done with our shear force calculation. So I'm going to clean this part for our bending moment calculation. Bending moment calculation. All right. So now let's go for the bend moment at point B. All right. The bend moment at point B is of course 0 because we stand at point B to the what? To the right. We only have force but no distance. All right. So the bending moment at point E now. All right. Bending moment at point E. If we stand at point E, we have an upward force multiplied by 4, ROB. And then our ROB is what? 231.139 multiplied by 4. So if you press that, we are going to have what? 0.556. kilonewton. This in kilo is just Newton meter, right? Yeah, Newton meter. All right. So now the next one is the bending moment at point D. All right, the bend moment at point D. So we are going to have ROB multiplied by total distance, which is 7. 231.139 multiplied by 7 minus 250 multiplied by what? Multiplied by 3. All right, so if we do this, what do we get? You said 867.973 Newton meter. All right, so the bending moment at point C now will be equals to ROB multiplied by total distance 231.139 times the total distance, that is 789, multiplied by 9 and minus 250 multiplied by what? Multiplied by 5 minus 300 multiplied by 2. All right, so if we do that, what do we get? 405. 405.991. All right, so that is going to be what? Newton meter. All right, so the bending moment at point A, bending moment at point A is going to be what? 0. Because sorry please, we have resolved this into y and s direction, so this is not 300, please. This mistake can cause you to have 0. All right, please don't make such mistake. All right, this when we resolve to y direction, when we resolve y direction, we have our y2 to be what? 212 point what? Point 0.13 multiplied by 2. So by the time you do this, this is the answer you get. All right, so now the next thing we are going to be doing is we are going to be drawing our shear force and bending moment diagram with the above information. We are going to trace down every point that we have load a straight line. All right, our shear force at point B is nothing but what? It's nothing but 231.139. so let's make use of this place. So we are going to, and between B and E we don't have any load, so we are going to make use of a constant line here. All right, so now, and the shear force at point E now is nothing but what? Negative 18.86. so let's make use of this point. So we're going to join this point down with this. All right, that is it. So between E and D there's no load, so we are going to join this to this. All right, so between at point D, the shear force at point D is negative 230.99. so we are still going down, so let's make use of these points. All right, and between that D and C we don't have any load, so we have a constant line here. All right, so that's it. All right, so the shear force at point C, at point C is nothing but what? Minus 405.99. so we are still coming down, so let's make use of this point. So this point. All right, so that's it. So this is positive, then this is negative. So yeah, let's shade. All right. All right. All right. So we are done with the shear force diagram. So for the bending moment, at point B, we have 0. All right, at point E, we have 924.55. All right, 924.55. I think that is the highest number that we have there. So it's going to be at this point. All right. So we are going to be using an inclined line to join these 2 points because we have a constant line here. So a constant line, our shear force diagram will be replaced with an inclined line, our bending moment diagram. All right. So now at point D, we have what? We have 867. So 867 will be somewhere around here. All right, somewhere around here. So now let's join this point to this point with an inclined line. All right. So at point C, we have 405.99. So 405.99 will be somewhere around here. Right. So let's join that point with this point here. All right. So then we go back to what? 0. So we closed this with what? 0. All right. So that's it. So you can shade now. So when you shade, it brings out the beauty of your work. Shows that you know what you are doing. All right. So this is going to be what? Positive. All right. So that is it. So this is our shear force diagram, and this is our bending moment diagram. So stay tuned for more interesting questions. Thanks.